Hi, I'm Mr. Franklin, and this is the video key for the electromagnetic practice test, page 12 and 13. Number one, what must be true in order for two particles to attract each other? So we're talking, this gets confusing because we finished up talking about magnetism, but now we're back to electricity. So for two particles to attract each other, they must have opposite charge. To repel each other, they must be like charges. Now, if this is a magnetic object, it has to have opposite poles or like poles. So a charge and a pole are not the same thing. Okay? Draw and label a model of the helium atom with three particles. When they say three particles, they're talking about a proton, neutron, electron, even though there's two of each. So this is helium. Remember that I've also done the N0. Is what I tend to do, and the P positive. But you can do that instead. That's what my chemistry version. It also gets into nuclear notation. So for nuclear equations, this is actually a better way to go. Okay, number three. Why don't protons in the nucleus repel each other? And it's because of the strong nuclear force, which is a force between the neutrons and protons, and it's stronger than the electromagnetic force. Remember, we said there are four fundamental forces of nature. There's gravity, electromagnetic force, strong force, and a weak nuclear force. And we've combined all three of those except for gravity. Gravity is the fourth one and remains unconnected to the others. And that's called string theory. Three most common phases of matter on Earth are solid, liquid, and gas. Number five, what does it mean if something is soluble in water? Solubility means it mixes uniformly. So this is food coloring. This is sugar dissolving in water. If it's so sugar is soluble in water, okay, because the water will dissolve it. There's some other words in there that can really get you confused, and you'll get to straighten those out in chemistry. Number six, write the formula for Coulomb's law and state what each variable means. So F is force, K is the electric constant, charge is Q1, and then you have a second charge, Q2, divided by the distance between the charges squared, and it's R because we are assuming these charges are spherical. In more advanced electromagnetism, we can't make that assumption, and that's when you get into calculus. Number seven, if you had two charged objects, what would happen to the force between them if the charge on one doubled? If charge doubles, then it's just doubling the entire equation. So if I double the charge, I multiplied this whole thing times 2, right? So the force is going to double. So if I do it over here, I have to do it over here, okay? If the distance tripled, so we're tripling this, but this is squared. So what's 3 squared? 3 squared is 9. It's not multiplying, it's dividing. So that means we're going to divide the force by 9. So we say it decreases by a factor of 9. Okay? So if this gets bigger, the force has to get smaller. Okay. What is the difference between a conductor and a resistor and an insulator? A conductor allows charge to flow easily. A resistor allows charge to flow but resists it. Love it when we use the definition in the word. Okay, so it resists the flow of current, and an insulator doesn't allow charge to flow at all. Plot the data in the table. Okay, so we haven't done a lot of graphing, so if you work through this, it's been a while, so notice that this is the x-axis, 1, 2, 3, 4. This is the y-axis, but notice it's inverted. We got big numbers on top, little numbers down here, and you're going to get this curve. Okay? And it should be, see, notice this is evenly spaced, 0, 20, 40, 60, 80, 100. But look over here, 100, 25, 11. So we got to make sure we're evenly spacing it. And because the graph is evenly spaced, when we plot 100, and then we plot 25, and then we plot, it results in this curved line. What's the IV and DV? Independent variable, always on the x-axis. Dependent variable on the y-axis. Okay, based on the line of fit. What's the distance between the objects when it is at 1.5 meters? So here's 1.5, and we're guessing it's about 40 newtons. Describes what happens to the force as the distance increases. So the distance gets bigger. Notice what happens to the force. It gets smaller, and it's at a decreasing rate. So if you had your pink sheet, you could use that. You could also talk about it, the square issue that we talked about above. Draw the magnetic field lines, north, north to south, north to south, north to south, north to south, north to south. Notice north to south, north to south, north to south. Notice the arrows. They're not making a circle. They're going from the north end, and they're pointing towards the south end on both sides. A lot of people make that mistake. So north to south. Non-magnetized, randomly pointing in all different directions. Highly magnetized, all lined up. Earth's magnetic north pole is actually the geographic South Pole. So South America is closer to the Earth's magnetic north. All magnets have two poles, north and south, even at the atomic level, north and south end. Like poles repel, opposites attract. How does electromagnetic induction occur? A current in a wire produces a magnetic field, and a moving magnet passed. Yeah, that's weird. Here, let me retype this. Electromagnetic induction. Current is, okay, so it can actually be two sides of the same coin. You can have a current creating a magnetic field, or you can have a magnetic field creating a current. Okay, and we actually use both principles at the same time to do all kinds of stuff. Okay, describe what electromagnetic induction is used for. Basically, generators and motors. So like wireless charging uses the electromagnetic induction to charge your phone. We got all the electrical generation. We got electric cars, which are motors. Your box fan that you're using to cool yourself uses electricity through a magnet to cause the fan to rotate, to cool you off. Okay, so electromagnetic induction, really cool stuff. One of my favorite topics. But that concludes the practice test, page 12 and 13. Please send me an email if you have any questions. I can go through something a little more deeply, because this is really just a quick overview. Most of the information is in the video notes. Thank you, and good luck on your quiz.